Hello everyone, I'm Dr. Sajad, and today we will discuss the solution of transportation problem with stepping stone method. So the procedure or the steps I have already written down so that we don't waste time on them. The steps are, there are 4 simple steps, and these 4 simple steps we will apply on the problem. So we will be given already solved or initially solved solution by any of the methods, either by northwest corner method or any other method. So you will be given the problem or initial solution, and you have to find out the optimized solution using the stepping stone method. So what is the stepping stone procedure? Is the first thing what you have to do is determine the improve index for each non-basic variables, which means cells with 0 values. So if you look at this one, there are cells where nothing was transported to. So nothing was transported from here, so there was 0 entry, 0 entry, 0 entry, and 0 entry. These are called non-basic variables. So here the variable was x21 and x12, x13, this was x11. So this x12 is a non-basic variable, this one is a non-basic variable, this one is a non-basic variable, and this one is a non-basic variables. The entries which has something in it, those are called basic variables. So you have to find out the improvement index for these 4 non-basic variables. How do we find that? I will explain that when I will solve this question. The next thing is, if a better solution exists, so if you find a solution, if you find that thing, the indices, then you will know that a better solution exists or does not exist. So if it exists, then you have to determine which variable should enter the basis variables. By that, it means that either this or this, in either of these 4, one should be improved. Which one should be improved? You will know which one should be improved. So that you have to increase that 0 into some number. So if, for instance, if you have to increase this one, this is called entering variable. So this would be non-basic, this will become basic, right? So that is called entering variable. So the values of this one would increase from 0. Then the next one says that determine the departing variables and the number of units assigned to entering variables, which means that from which value should that number be subtracted. So it means that, for instance, if this is the entering variable, which means this 0 should be increased. So either this or this, any of these 3 should be decreased. Which one should be decreased? So this is called entering variable, and the variable from which you will subtract something and add it here, that is called leaving variable. So you have to find out that variable, and then you have to develop a new solution. So once that is done, you will find out a new solution. So this whole table will change, and then again you will do the same steps. So let's come to the first step. So what was the first step? To find out the index, right, of these ones. So you have 3 cells. The first cell is at 1 and 2. So I would call it 1, 2. So this is the cell, right? Then you have another cell which is non-basic, is this one, which is at 1 and 3. So I would write there at 1 and 3. Then you have 3 and 1, 3 and 1, and then you have 2 and 3. So you better write down 2 and 3, and 3 and 1. Now how do we find the index is you have to find out a closed loop. You start from here, you start from the cell and go in horizontal and vertical lines, right? And it has to have only 0 1 time. So if you are starting from here, right, it cannot go here, it has to go here, right? So it can have this 1 0 but not this one, so it has to go there, here, right? And then again it cannot come here because there is another 0. So in the whole loop you would have only 1 0. So if I start from here, that is cell 1 2, I start from here, I can go here, right? That is 1 1. So I can go from this to 1 1. Then from this one I can go to 2 1. Now from 2 1 I can go to 2 2. And from 2 2 again to 2 1. So this is a closed loop. You are back to 1 2, right? So this is called one closed loop. Now you have to find out all the closed loop for all the non-basic variables. So this is the first one. For the second one you have, let's find out the simple ones first. So this is another one is simple. You can go here, here, here. So goes there, that, and this one. So for 3 1 you can go from 3 1 to 3 2. From 3 2 you can go up to 2 2. From 2 2 you can go back to 2 1, and from 2 1 again you're back to 3 1. Now another simple one is this one. So 2 3 you can go from 2 3 2 to 2. You can go from this 2 to 3. From 2 3 you can go to 3 2. Sorry, 2 2. From 2 3 you can go to 2 2. And from 2 2 you can go to 3 2. And from 3 2 you can go to 3 3 and back to 2 3. Now this one is a little complicated, and here you can apply the rules. So the first rule is you can have only 1 0 in the closed loop. So if I start from here, where I can go either here or I can go either here. So if I go here, so from 1 3, where did I go? To 3 1. Now from 3 1, where can I go? I can either go horizontally or vertically. Vertically is already done, so I can go horizontally to this cell, which is 3 2, right? And now from 3 2, from this cell I can go either horizontally or vertically. Horizontally is 0. We're not allowed to add another 0 because we already have a 0. So we have to go up. That is, we're going to the cell 2 2. Now again we are allowed only horizontally or vertically. If I go horizontally we are going to 0. If I go horizontally to that side, 0. Vertically 0. So where I can go is to horizontally on the left side. So if I go there, I am in the cell 2 1. Now again here, if I come here, from here I can only go either up or down. So if I go down, there is 0. We're not allowed to add another 0, so we can go up. This is the cell which is 1 1. And now from this cell you can skip this one and jump back to the cell. So you have a closed loop, right? You are back to the same cell. So these are four closed loops for this cell, this cell, this cell, and this cell. And these are your non-basic variables or non-basic cells which you have to improve. And you have to see whether the improvement is, if there exists an improvement or not. So for the first one, for the cell 1 and 2, so what we have to do is you add a plus to the cell that you are. So you are adding a plus here. It means if you add 1 ton or 1 unit to this 0, what will happen to the overall cost, right? So if I add something, or for instance 1 unit to this, the supply is increased. We had only 55, but now we have 1 more. So obviously if we have 1 more, we have to subtract it. So we minus that from here. If we're talking about this loop, then we added something here, the supply was increased, so you subtracted it within that loop. Again, if you subtracted it, then the demand was, 1 was decreased from the demand. So what we have to do is add 1 to the demand. Now we have added 1 to the demand to fulfill the demand, but what we have done is we have increased the supply now here. So we have to subtract that from the supply. So you have to add and subtract in that manner with each and every loop. So plus, minus, plus, minus, right? So plus, minus, plus, minus, plus, minus. Now you have to multiply the cost. So plus 1, so the cost is $10, so it means it will cost you $10 for 1 ton. And here minus $5 plus $20 and minus $30. So for this cell it would be 1 plus 1 times 10 plus minus 1 times 5 plus 1 times 20 and plus minus 1 times 30. You can calculate them. 10 minus 5 plus 20 minus 30. So that is minus 35 plus 30 gives you minus 5. Which means that there is improvement possible. The negative means that the transportation cost can be minimized, further minimized. So there is improvement. For the next 1 and 3, so if this is positive, right, then this is negative, then this is positive, then this is negative, then this is positive, then this is negative. So again, you can calculate that 1 times 10 plus minus 1 times 30 plus 1 times 20 plus minus 1 times 30 plus 1 times 20 plus minus 1 times 5, and you add them up. So that is 10 minus 30 plus 20 minus 30 plus 20 minus 5. So minus 30 is 60, and this one is 20, 20, 40, 50, minus 10, that is minus 15. So this means that the margin of minimization in this one is more than this one. Now you can go to the other cells, this one, which is cell 3-1, so that is 1 times 10, this is positive, so this would be negative, minus 1 times 20, again this one, this is positive, this is negative, this is positive, 1 times 30 plus positive, negative, positive, negative, minus 1 times 20. You have to multiply it with the costs, not with these values. So that gives you 10 minus 20 plus 30 minus 20. So minus 40 and plus 40 gives you 0. It means there is no improvement. 0 means no improvement. And the last one is this one, which is 2, 3. So for this one, this is positive, means 1 times 20, negative means minus 1 times 30, plus positive again 1 times 20, plus negative again minus 1 times 30. So that gives you 20 minus 30 plus 20 minus 30, and you can see that that is minus 60 plus 40 gives you minus 20, and the margin on this one is even more than this one. So you have to look for the negative numbers. If there are no negative numbers, it means there is no chance of improvement. The solution is already improved. If there are negatives, you have to look for the maximum or the most negative value, minus 20. So now what we have is, we have found out that this one has minus $5 profit margin, this one has minus 15, so $15, 2 has, sorry, dollar minus 20, and the last one, it has $0. So the margin in this one is larger. So this one is entering variable, which here it is 2, 3. So 2, 3 is your entering variable. Entering variable is x. 2, 3, right? And how much you can put here. Now for 0, now there is no number, or 0 is the number. So how much value you can add in here. So if you look at this one, the supply is 80. So we can take up to 80 tons, or 80, number 80 from here into this one. But if we see at the demand is only 40. So we add 40 into here, right? So once we added 40 here, that 40 is extra, right? That is added. So the demand, if you look at the demand, so we had in the loop, this was positive, this was negative, this was positive, and this was negative, right? So if you look at this one, this condition positive, negative, positive, negative, this shows that you can add here something that you have to subtract from here or from here, right? So how much we can subtract from here or how much we can subtract from here. So if you see, this is 65. We can take all of the 65 from here and bring it here. But if we look at the demand is only 40. So how much we can subtract from here and bring it here? The demand is 40, so maximum we can take up to 40 from here and take it here. So if we subtract 40 from 65, 65 minus 40, here we are left with 25. So this is left 25. This is 40. We added 40 to it. We subtracted 40 from here, so we are left with 25. So nothing, if you add these three, it will give you 80. Nothing has changed over here. But if you look at this one now, the demand was 40, now the demand is 80. It means if you added 40 here, we have to subtract 40 from here. So here, the demand, the value is 0. So this variable, which is 3, is leaving variable, is x33, because that becomes 0. So if you subtract 40 from 40, this gives you 0. And now here, how much you have to add in 35 to make it 100? That is 25 and that is 35. Here the supply is 75. So if you add 25 and 35, that gives you 560. So how much you have to add to make it 100 is 40. So you add that 40 up here. So that becomes 75. So you can see the supply is 75, the supply is 80, you add them up 80, the supply is 55, is 55. The demand is, add them up 70, the demand is 2, add them up 100, the demand is 40. So the table is now complete. Now this was the entering variable, now this is the basic variable, this is the leaving variable, now this is the non-basic variable, right? Now you have to calculate the cost again. So the first cost that we calculated was $425. And now you can calculate the cost again. So the cost would be 5 times 55 plus, this is 0, this is 0, I'm not going to calculate that, 15 times 20 plus 25 times 30 plus 40 times 20 plus, this is 0, I'm not going to calculate this one, plus 75 times 20, and that one is 0, so we don't need to calculate that one. So this one is 5, 25, and that is 25, so 27. That is again 300. That is 0, 6, 7. Again, this one is 800 plus 0, 0, 14, and 15. So you can add them up. 1500, 300, 800, 275, 750, that is 5, 12, 1, 5 and 8, 8, 8, 16, 16, 17, 18, 18, 25, 25, 26, and 3. So you can see that the cost now is $36.25. So the cost is, the first cost was $4,425. Now when we improved, now the cost is $3,625. Now again you have to repeat the process. You have now this non-basic variable, this one, and this one. You have to find out again for the cell 1 2 a closed loop. You have to find out the closed loop for cell 1 3, for the cell 3 1, and for the cell 3 3, and find out if there is any negative in here. You have to, there is a chance of improvement. If they are 0 or positive, it means the solution that you already have is the improved solution. Thank you very much.